everyone. My name is DHRUVISH Kanani and today I will be presenting my assignment 3 for COM 3132. This assignment explores two important areas in image processing and deep learning. Part A focuses on using image convolution to detect edge in images, and Part B divides into building and training neural networks to classify images from the CIFAR-10 datasets. This hands-on experience has helped me understand how image data can be transformed and interpreted using Python and machine learning. Part A: Image convolution and edge detection. Step 1: Loading and preparing the image. To begin Part A, I imported necessary libraries like NumPy for matrix operations, PIL for image loading and conversion, and Matplotlib for visualizing results. I loaded an image from an online source, converted it to grayscales to simplify the analysis, and turned into NumPy era. Grayscales images are easier to process because we only need to handle intensity values or not RGB colors channels. Step 2: Applying custom kernels for convolution. Next, I perform image convolution using custom defined kernels. Convolutions is an operation where we slide a small matrix called a kernel over the image to highlight certain features like edge and patterns. PD was applied to the image to maintain dimensions after convolutions. 45-degree and 135-degree diagonal kernels were used to detect lines at specific angles. Using a nested loop, I moved the kernel across the image, multiplied corresponding pixels value, and stored the result to form a new output image. Step 3: Edge detections with common kernels. After basic pattern detection, I use three more advanced kernels for edge detection. One diagonal kernel to detect slanted edges, horizontal vertical kernel like Sobel, which captures clear edge and outlines, Laplacian kernel for detecting edges in all directions by computing the second derived values. The filtered image were then plotted, allowing me to visually compare how each kernel affect the image differently. This gave me a deeper understanding of how different filters are designed to extract different types of features. Deep learning with neural networks. Step 1: Dataset preparation. For Part B, I used the CIFAR-10 dataset, which includes 60,000 images across 10 classes like airplanes, trucks, birds, and cats. I divided the datasets into training and testing sets. One hot encoding was applied to label to convert them into a machine readable format. I normalized the pixel values to a range between 0 and 1 to speed up training and improve model performance. Step 2: Building the CNN model. I created a convolutional neural network using keras. CNNs are powerful for processing images because they automatically learn to extract features. The model included a convert 2D layers with 32 filters to extract basic features, a max pooling layers to reduce dimensionally and prevent overfitting, a flattened layers to convert 2D features into 1D vectors, a dense layer with 1 to 8 neurons using D-loop activation, and output layers with 10 neurons using softmax for multi-class classification. The model was compiled using the Adam optimizer and categorical cross-interval loss, and trained for 50 epochs. A custom callback printed training accuracy every 5 efforts. Step 3: Evaluating performance. During training, I monitor both training and validation accuracy. I noticed that while training, accuracy improved significantly. Validation accuracy plateaued, indicating overfitting. Part C: Enhancing the model with dropout. Step 1: Adding layers and dropout to fix overfitting. I redesigned the model by adding another convolution layers to capture deeper features. introducing a dropout layers to randomly deactivate neurons and force the model to generalize better. Step 2. Comparing model version. I tested or compared three versions: initial model, extended model, dropout model. Conclusion. To wrap up, assignment 3 was an exciting blend of classical image processing and modern machine learning. I learned how convolution kernels can reveal hidden patterns in images and how CNNs learn those features automatically to classify images. I also learned how to handle overfitting using dropout layers and how small architectural changes can significantly impact accuracy. Thank you so much for your time.